Because of the gain, we must subtract 2 inches from the 25 inches to give us an accurate measurement from bend mark A to the edge of the obstruction of 23 inches as shown in figure 13 to 27. To pre-position the 45 degrees offset using method number 1, we take the height of the obstruction and add the offset constant for the size pipe we are using. In this case the offset height is 8, and the offset constant for 1/2 rigid conduit using a Chicago style bender is 5 inches, table 13 to 23. Height of obstruction, h, 8, plus, offset constant for 1/2, EMT, 5 inches, total 13 inches. Distance from bend mark A to the obstruction 23. Subtract h plus offset constant minus 13 inches, 10 inches. Measure 10, from bend mark A and mark bend mark B, as shown in figure 13 to 28. The measurement from bend mark B, the start of the offset, to bend mark C would be found by multiplying the height of the obstruction by the offset multiplier for a 45 degrees offset. Offset height 8 inches by 1.414 equals 11.312. Round up to 11 3/8, for the spacing between bend mark B and bend mark C, as shown in figure 13 to 28. To locate bend mark D, it will be easiest if we use marca as a reference. The back-to-back measurement from the back of the first 90 degrees bend to the back or the second 90 degrees bend is shown in figure 13 to 24 as 37. Between bend mark A and D there is one 90 degrees bend and an offset. For the 90 degrees bend we will subtract 2 inches for gain, but then we must add shrink for the 8 inches offset. Shrink for the 8 inches 45 degrees offset would be 8 by 3/8, equals 24/8 or 3, or total shrink. 37 inches back-to-back distance. Plus 3, shrink 40 inches 2 inches gain 38 inches distance from bend mark A to bend mark D as shown in figure 13 to 28. We can, and should, always double-check our measurements before bending the pipe. The best way is to work backwards, or from the opposite end that we originally measured from. Starting from box Y, the measurement to the back of the 90 degrees bend is 22 inches plus 5 inches for take-up and then minus 2 inches for gain, or 25. From the end of the pipe at Y to bend mark D as shown in figure 13 to 28. From D to A, as shown in figure 13 minus 28 is 38. Add 38 inches to 25 inches for a total of 63 inches from the end of the conduit at point Y to bend mark A. From A to box X is 18 inches minus 5 inches of take-up, or 13. Add the 13 inches from X to bend mark A to the 63 inches measurement for bend mark A to the end of the conduit at Y for a total length of 76. Which was the calculated total length. By taking the time to make these extra calculations, any mistakes that might have been made will be found. We can now proceed to bend the pipe with the confidence that the end results will be a pipe that fits right the first time, without adjustments. The next problem will have a 4-bend saddle and two 90 degrees bends. As with offsets, method #I must be used for push-through bending 4-bend saddles. If necessary, review Chapter 9 for pre-positioning 4-bend saddles using method number 1. Lay out the pipe as indicated in figure 13 to 29. The pipe will be 3/4, rigid, the take-up is 6 inches, the gain for each 90 degrees bend is 2 3/4, and the saddle is bent using 45 degrees bends. First find the total length. Measurement of the two stubs and the back-to-back measurements are 16 plus 63 plus 18, for a total of 97. To this value add the shrink for the 4-bend saddle. Remember that there will be 2 shrinks, one for the first 2 bends and another for the second 2 bends to complete the saddle. Height of the obstruction is 6 inches, double this to give us 12. Now multiply 12 inches by 3/8 to find total shrink. 12 inches by 3/8 equals 36/8 or 4.5 of shrink. Add the 4.5 to the previous measurement of 97 inches for a total of 101 From this total we must now subtract gain. There are 2 90s so the gain will be 2 by 2 3/4, or 5.5, of total gain. Total gain of 5.5 is subtracted from the 101.5 measurement for a total pipe length of 96 inches, as shown in figure 13 to 30. To locate bend mark A, subtract the take-up of the bender, which was given at 6 inches, from the desired stub length of 16. 16 inches 6 inches equals 10. The distance from the end of the pipe at box X to bend mark A is 10, as shown in figure 13 to 30. The distance from A to B, from A to the back of the bend is 6 inches, take up, minus 2 3/4, for gain. 6 to 2 3/4 equals 3 1/4. The edge of the obstruction is 32 inches from the back of the bend. By adding the 3 1/4 to the 32 inches, we have a measurement of 35 1/4. That represents the distance from bend mark A to the edge of the obstruction. 35 1/4, 12 inches equals 23 1/4. This is the distance from bend mark A to bend mark B, as shown in figure 13 to 30A. The distance for B to C. The distance from B to C is found by multiplying the height of the obstruction, 6 inches, by the offset multiplier for 45 degrees offsets, 1.414. 6 times 1.414 equals 8.484 or equals 8.5. The spacing from B to C then is 8.5, as shown in figure 13 to 30A. The distance from A to R. Previously we had located the edge of the obstruction from bend mark A, which was 35 1/4. If we add the shrink for the first two bends of the saddle to 35 1/4, we have located the reference mark R. The shrink would be the height of the obstruction multiplied times 6 inches by 3/8 equals 18/8 or 2 1/4. The distance from A to R then is 35 1/4 plus 2 1/4 equals 37 1/2, as shown in figure 13 to 30A. Distance from R to D. The distance from R to D will be the width of the obstruction. The obstruction is 10 inches wide, so the distance from R to D is 10, as shown in figure 13 to 30A. Distance from D to E. The distance from D to E will be the same measurement as B to C, 8.5, as shown in figure 13 to 30A. Locate bend mark F. Bend mark F may be located from A or R from R to F. The back-to-back measurement for the two 90s is 63. It is 32 inches from the back of bend A to the edge of the obstruction, so it must be 31 inches from the obstruction to the back of bend F, as shown in figure 13 to 29. If we add 2 1/4 of shrink for bends D and E to 31 inches, we get a measurement of 33 1/4. All we need to do now is subtract 6 inches for take up from 33 1/4 to get a measurement of 27 1/4 from R to F, as shown in figure 13 to 30A. From A to F, back-to-back measurement from bend A to bend F is 63 inches, distance, plus 4.5, total shrink, minus 2 3/4, 1 gain, equals 64 3/4, as shown in figure 13 to 30A. To make sure that we have not made any mistakes, we will double-check our figures by locating bend mark F again, but starting from the Y end of the pipe. From the Y end of the pipe we can locate bend mark F by adding the stub length of 18 inches, plus 6 inches for take-up, and then deducting 2 3/4 for gain. 18 inches plus 6 inches equals 24. 24 inches minus 1 gain of 2 3/4 equals 21 1/4. From the Y end of the pipe to bend mark F will be 21 1/4, as shown in figure 13 to 30A. Adding this measurement, 21 1/4, to the measurement we have already found for the distance from A to F, 64 1/4, we would get a total of 86. Add the 10 inches from bend mark A to the X end of the pipe to the 86, and we get the total pipe length of 96 inches as shown in figure 13 to 30B. Laying out a pipe with this many bends may seem very complicated at first, but with a little practice you will be able to do it rather easily. The key is a complete understanding of take-up, gain, shrink and offset constant values. Problems. 1. Find the total pipe length, need and lay out the bend marks as required for the pipe job shown in figure 13 to 31. The pipe size is 1/2, rigid, the bender take-up is 5 1/4, the offset is 45 degrees, and the gain for each 90 degrees bend is 2 3/8. 2. Find the total pipe length, need and lay out the bend marks as required for the pipe job shown in figure 13 to 32. The pipe size is 3/4 EMT, the bender take-up is 6 inches, and the gain for each 90 degrees bend is 3 3/8. 3. Find the total pipe length needed and lay out the bend marks as required for the pipe job shown in figure 13 to 33. The pipe size is 3/4, rigid, the bender take-up is 6.5, the saddle is bent using 45 degrees bends, and the gain for each 90 degrees bend is 3 1/4. Predetermining saddle location. Using a Chicago style bender. When using Chicago type bending equipment, an adjustment must be made to assure that the saddle will be centered on the obstruction. The adjustment is necessary because the bend will not actually start at the bend mark, as was the case with a hand bender, but will be back of the bend mark. Place the bend mark at the start of the bending shoe and bend a 45 degrees bend as shown in figure 13 to 34. Take the pipe out of the bender and mark where the bend actually starts. The distance from the bend mark to where the actual bend starts is the amount that will be deducted from the width of the obstruction to assure that the completed saddle will be centered on the obstruction. Figure 13 to 35 shows how the saddle would fit if no adjustment is made, while figure 13 to 36 shows how the saddle will fit when the correct adjustment has been made. The amount of adjustment will vary with different types of benders. The only way to determine the correct adjustment for the bender you are using is to bend a scrap piece of pipe. 3 bend saddles using Chicago-style benders. When using a Chicago-style bender for bending 3 bend saddles, the multiplier will be 3, not 2.5 as was the case with bending EMT using a hand bender. When a multiplier of 3 is used, the bend marks for each of the 3 bends that make up the 3 bend saddle will be center of the bend marks, not the front of the shoe marks. To find the center of bend mark for your Chicago-style bender, 1. Bend a scrap piece of pipe to a 45 degrees bend. Take the pipe out of the bender and determine where the center of the 45 degrees bend is. Mark the pipe and put it back into the bender lining the original bend mark with the front of the bending shoe. Now place a mark on the bender shoe that corresponds with the mark on the conduit. You now have a mark that represents the center of the bend for 45 degrees as shown in figure 13 to 37. This mark on the bender shoe will be the mark that will be used to bend both the 22.5 degrees bends as well as the 45 degrees bend that will make the 3 bend saddle. Example. Bend a 3 bend saddle to go over an 8 inches diameter pipe. The spacing between bend mark A and bend marks band C is found by multiplying the diameter of the pipe, 8, by the multiplier of 3. The spacing then between bend mark A and B and A and C will be 24, as shown in figure 13 to 38. Place the conduit in the bender lining bend mark B on the mark on the bender shoe that indicates the center of a 45 degrees bend. Bend a 22.5 degrees bend. Rotate pipe 180 degrees and advance pipe to bend mark A. Bend a 45 degrees bend. Rotate the pipe again 180 degrees. Advance the pipe to bend mark C and bend a 22.5 degrees bend to complete the saddle. General, Chicago-style bender tips. 1. To reduce the time it takes to convert fractions to decimal equivalents or decimal values to fractions, purchase a pocket calculator that will do fractions. To do fractions, the calculator must have a ABC key. To enter the fraction 3/8 as an example, you press the ABC key, then the number 3 key, then the ABC again followed by the number 8. The calculator will display the fraction 3/8. You can then multiply, divide, add or subtract. 2. When minimum length stubs are being bent, the shoe tends to creep and deform the ends of the conduit and threads. Screwing a coupling on the pipe stops the shoe from creeping forward and protects the pipe threads. 3. When bending offsets, the front of the bender can be temporarily elevated to gain necessary clearance for the bends. 4. Most bender shoes are made of cast aluminum and are easily pitted and gouged if foreign material gets between the shoe and the pipe. Keep the pipe clean and the shoe wiped down for longer shoe life. 5. When the remaining pipe length is not long enough to reach the roller or pipe support, a larger diameter pipe can be slid over the pipe being bent to complete the bend as shown in figure 13 to 39, or if the pipe has threads, screw on a short piece of scrap pipe. 6. To prevent wows and dog legs when bending offsets and saddles, use a wow watcher, or no dog as shown in figure 13 to 40. This device screws onto the end of the pipe to maintain correct alignment between each bend. 7. For matching bends in sizes 1/2, 3/4, and 1 inch, all bends can be made using the 1-inch bending shoe. Hydraulic benders. 14. For bending larger sizes of conduit, the hydraulic bender is indispensable. Only by the addition of the hydraulic pump and cylinder to a bender frame is the necessary power available for bending rigid conduit up to 6 inches trade size. The typical completely assembled hydraulic bender is shown in figure 14 to 1 not only gives the electrician extended bending capability, but also requires additional responsibility. Hydraulic bending equipment represents a large initial investment of money, and the bender must be properly cared for if it is to last and give the service necessary to justify the cost. The bender frame, pivot shoes and bending shoes will require little more than occasional wiping down with a rag to remove the dirt and oil film. The pump, cylinder and hydraulic hoses, however, will demand more attention. Hydraulic benders will come with quick, disconnect couplers on the pump, cylinder and hoses. Each coupler end, whether male or female, comes with a dust cover as shown in figure 14 to 2. The male coupler is on the left and the female coupler is on the right. These dust covers must be in place when the bender is disassembled to keep dirt and dust out of the couplers. Failure to keep the couplers clean will result in damage to the zero rings hydraulic pressure depends on the 0 rings seating and sealing properly. The pump, whether hand or electrically operated, should have the fluid level checked periodically. Low fluid pressure will keep the pump from developing its rated hydraulic pressure. When the fluid level is low and fluid must be added, use only approved hydraulic oil. Ordinary oil will cause damage to the pump assembly. Figure 14-3 shows a hand hydraulic pump, while Figure 14-4 shows an electric hydraulic pump. Hydraulic benders have two types of bending shoes, one-shot and segment. The one-shot shoe has a full 90 degrees radius. The conduit can be formed around the shoe to a full 90 degrees bend without collapsing the walls of the pipe. One-shot benders require no new bending techniques. The take-up is figured to the center of the bend and the bender shoe will have a mark at its center as shown in Figure 14-5. If the take-up values are not listed on the bender frame or on the storage box, scrap pipe can be bent and take-up values can be determined. All the methods and layout techniques discussed for EMT and rigid can be used with a hydraulic bender and one-shot shoes. Offsets will have to be adjusted, less angle of bend, so the spacing between the bend marks are far enough apart to allow the first bend to be rolled 180 degrees and advanced enough to clear the pivot shoes. The pivot shoes are shown in Figure 14-1. Segment shoes are shorter and have a very limited radius as can be seen in Figure 14-6. 90 degrees bends cannot be made in one operation with a segment shoe as the conduit walls will collapse. Bends must be made in several steps, as few as 4, and as many as 30, to form a smooth radius. The segment shoe allows pipe to be bent to larger size radii. Segment shoes are used for concentric bending. Concentric bending is when several conduits are bent with increasing or decreasing radii. Figure 14-7 shows three pipes that have different radius bends. To maintain correct spacing between the pipes, the radius of each pipe will be different. The inside pipe will have one radius and then the next pipe will require a larger radius and the third pipe will require an even larger radius to maintain proper spacing. Concentric bending is covered later in the text. Accurate bending of large conduit is possible, but requires practice, patience and ability. With few exceptions, all formulas and bending techniques discussed to this point will apply. One-shot shoes can be used for segment bending, but are not as convenient. Bending tips for rigid aluminum conduit. Aluminum conduit is available in all trade sizes, 1/2 through 6. It is lightweight, corrosion resistant and has low ground impedance. It is, however, difficult to bend consistently and accurately. Two pipes out of the same bundle can act differently when bent. Even if two pipes are bent using the same layout, they don't always come out exactly the same. Don't be discouraged, this is the nature of the metal, and it can't be helped. The one-shot hydraulic bending shoe will dig in and score the pipe, and where the pipe rides on the pivot shoes it is also prone to wrinkling and scoring. Applying petroleum jelly, Vaseline, to the shoes will allow the pipe to slide without the shoes digging in. The Vaseline will also make it easier to remove the conduit from the bender shoe when the bend is completed. Layout 4. Segment bending 15. Segment bending will require some new information and bending techniques. Segment bends, as mentioned earlier, require more than one bend to complete a 90 degrees stub. As many as 30 bends may be used and would require 30 bend marks. The first step in segment bending is to determine the size of radius that is needed for a given pipe job. The larger the radius, the easier wire pulling will be. Space requirements and installation location will also be a factor that will govern the radius of a given pipe. The National Electrical Code gives the minimum bend radius for conduit and tubing in Table 2 of Chapter 9. Table 2, Chapter 9, Radius of Conduit and Tubing. For factory 90 degrees or field bends made with a one-piece shoe, the first column of Table 2 is used. When bends are made with multiple bends, the column, Other Bends, is used. In all cases the minimum radius of bend is measured to the center line of the conduit or tubing. If you don't have access to the table, a rule of thumb that is used to determine the radius for a given pipe size is 6 to 8 times the trade size of the conduit or tubing. Notice in Figure 15-1 that the bent portion of the 90 degrees bend makes up 1/4 of the circumference of a circle. Also note that 1/2 the diameter is called the radius, r. To find the circumference, c, of a circle, use the formula c equals pi x diameter. The Greek letter pi, which is the ratio of the circumference, c, of a circle to its diameter, d, has a value of 3.14. The formula can be rewritten as c equals 3.14 xd. To find only 1/4 of the circumference, which is the amount of bent pipe, we can modify the formula. As pi, 3.14 is the ratio of the circumference to diameter of the circle. We can use half the value of 3.14, which is 1.57, and use the value of the radius instead of the diameter. The revised formula is 1/4 c equals 1.57 x radius. The amount of pipe that is actually bent to make a 90 degrees bend, 1/4 the circumference, is called the developed length. Stated another way, developed length is the amount of straight pipe required to bend a given size of radius as shown in figure 15:2. The developed length for a 90 degrees bend is equal to 1/4 of the circumference. The formula for finding developed length for 90 degrees then is developed length equals 1.57 x radius. As indicated in figure 15:3, the radius is measured on the inside of the bend. The radius plus the outside diameter of the pipe is just like take up, as described in earlier chapters. Note: a full list of outside diameters for all pipe sizes is found at the back of the book. The amount of the radius plus the outside diameter subtracted from the desired stub length will give us the start mark. The start mark is used for layout only and is not a bend mark. Example: to locate the start mark for laying out a 4 inches rigid conduit with a 48 inches stub that has a radius of 24 inches, we add the outside diameter, OD, for 4 inches pipe, which is 4.5, to the 24 inches radius and subtract that value from 48, the desired stub length. Start mark equals 48, 4.5 plus 24, start mark equals 19.5, as shown in figure 15:4. The start mark, as well as all other bending marks, should go at least halfway around the pipe. If the marks are too small, they will be covered up by the bending shoe and create a problem when the bending is started. As more than one bend must be made to complete the 90 degrees stub, the next step then is to determine the number of bends to use. The number of bends is also referred to as shots. Figure 15:5 and 15:6 are exaggerated, but serve to illustrate a point. The more bends, the smoother and uniform the radius will be. Examples of the number of bends in degree per bend for 90 degrees segment bending are shown in table 15:7. Normally the degrees per bend should not be less than 3 degrees, 30 shots, nor more than 6 degrees, 15 shots, for a smooth and even radius bends. Any degree between 3 degrees and 6 degrees of course can be used. An angle finder or digital level will be necessary if accurate results are to be expected. Remember, the more bends the smoother the 90 degrees stub and the easier wire pulling will be. Once you have decided on the number of bends to be used, shots, the number is divided into the developed length, the amount of straight pipe needed to bend a given radius, to give us the spacing between the bend marks as shown in figure 15:8. Spacing between bend marks is equals developed length. Number of bends. Example: determine spacing between bend marks for a 22 inches radius bent in 20 shots. 20 shots is the same as 20 bends. Developed length equals 1.57 x radius. Developed length equals 1.57 x 22. Developed length equals 34.54 or degree 34.5. To find the spacing between the bend marks, divide the developed length by the number of bends, shots. Spacing equals 34.54 divided by 20. Spacing equals 1.727 or equals 1 3/4 between the bend marks. Now that the new terms and formulas are understood, let's put it all together and lay out 2 segment bends. Example number 1. Lay out a 3 inches rigid pipe that will have a radius of 24 and a 90 degrees stub length of 42. The pipe will be bent in 20 shots of 4.5 degrees per shot. Find developed length. Developed length equals 1.57 xr. Developed length equals 1.57 x 24. Developed length equals 37.68 or equals 37 5/8. 2. Determine the location of the start mark. Start mark equals stub length, radius plus pipe OD. The OD for 3 inches rigid is 3.5. Start mark equals 42, 24 plus 3.5. Start mark equals 42 to 27.5. Start mark equals 14.5 or 14.5. 3. Spacing between the bend marks. Spacing equals developed length divided by number of bends. Spacing equals 37.68 divided by 20. Spacing equals 1.884 or equals 1 7/8. Starting at 14.5, from the end of the pipe, place 20 marks 1 7/8 apart, as shown in figure 15:9. 4. Conduit is placed in the bender and bent 20 times. 20 bends of 4.5 degrees will equal 90 degrees. Asterisk: remember, the start mark is not a bend mark. Note: Complete bending instructions are covered in the next chapter. Example number 2. Lay out a 4 inches pipe that has a stub height of 51, a 30 inches radius, and bent in 15 shots, 6 degrees per shot. 1. Find the developed length. Developed length equals 1.57 by 30 inches, radius, developed length equals 47.1. 2. Locate the start mark. Start mark equals desired stub height, 51, minus the radius, 30 inches, plus OD of the pipe, 4.5. Start mark equals 51 inches, 30, plus 4.5. Start mark equals 51 inches 34.5. Start mark equals 16.5. Locate the start mark 16.5 from the end of the pipe. 3. Find spacing between the bend marks. Spacing equals developed length divided by shots, 15, spacing equals 47.1 inches divided by 15, spacing equals 3.14, or equals 3 1/8. 4. Starting at the start mark 16.5, from the end of the pipe place 15 marks 3 1/8 apart on the pipe. The pipe is now ready to bend. Problems. 1. Find the start mark and bend spacing for a 2.5 conduit with a 24 inches radius, a 62 inches stub using 20 shots. 2. Find the start mark and bend spacing for 4 inches pipe with a 40 inches radius, a 68 inches stub using 30 shots. Of the several methods of layout in use for segment bending, the author has elected to use the one he feels is easiest to remember. The success of the method described, as with any method or technique, depends on the electrician's mechanical ability and the equipment being used. Note: no matter which bending method is used, if for some reason your stub lengths are consistently too high or too low, make certain you are performing the bending procedures correctly, then adjust your layout to compensate. It is extremely important that you check your developing stub length and angle of bend when you have 4 or 5 shots left to bend. Corrections or adjustments can be easily made during these last few bends to bring the stub to the correct length or to complete a full 90 degrees bend. If the stub is coming up long, bend more degrees of bend for each remaining shot to bring it up to a full 90 degrees without adding additional stub height. If the stub is coming up short, lengthen the spacing between the bend marks to pick up the necessary added stub length without bending over a 90 degrees bend. Note: a wallet-sized cutout card with the formula for segment bending is located on the last page of the book on green cardstock.